Okay, one of the main types of things we use in mathematics is a type of thing called a set. And set, I don't know, I'm going to call this a definition, but a set is a collection of objects. One problem a student could have with this is, well, what's a definition for collection? What's a definition for objects? Obviously, not every single term in math can be defined because you'd have to define the words used in the definition and the words used in that definition and so on. The words we choose not to define are words that actually we all have fairly common agreement on, so we don't hopefully need to define them, and we're all still pretty much or hopefully completely on the same page. And so we all have a pretty good idea of what a collection is, like a collection of baseball cards or a collection of marbles or something else. Or, as you know in math, most of the things that we're going to work with, the collections are going to be of numbers, obviously, for a math class. As an example of this, most sets in math are named A, B, or C, usually with capital letters, and so I could say the set A contains the numbers 1, 2, and 3. So notice this set actually has 3 numbers inside of it. We separate the objects in the collection with commas, and to show they're collected together, we put braces around them. So the braces show this collection, which we have named A, this A will equal a set containing the objects or numbers 1, 2, and 3. As another example, we could take this same set and call it 2, 1, and 3. In other words, a set has no order. If you rearrange, at least, I know there are some sets like a baseball card collection you would want to put it in order, but it's the same baseball card collection even if you shuffle it. And similarly here, if we rearrange the objects in this set A or the 3 numbers, it's still the same set or collection of numbers. One other thing you want to be aware of, what if we had the number, let's say 1 in here twice? I could write 2, 1, 1, 3. This is just by agreement among mathematicians wrong. We do not do that. If a number is in a set twice, you still only list it once, so don't relist duplicates. Oops, I spelled duplicates wrong. Don't relist duplicates. That we don't list a number, for example, in a set even if it occurs twice, and that's the basic idea of sets, that a set again is a collection of objects. Another thing that you want to be aware of then here is we have a few other terms here that I'm not going to focus on too much, but suppose we have A be the set 1, 2, and 3, and let's let B be the set 1, 2, 3, 4, and 5. There are a few things I want to show you here. Notice the number 4 is inside B but not in A. What we say here then, we say 4 is an element or object in the set B. There's actually notation we can use to show this. We write 4 is an element of the set B. That looks kind of like an E, but it's not exactly the same. It's almost like a semicircle with a line through the middle. It's an element of symbol. And notice 4 is not an element in set A. And the way that we show this is to write 4, well, we could write as an element of A, but that's not true. And as you know, for like no smoking or something else, or the Ghostbusters symbol, no ghosts, that you say just write a slash or to show it's not true. This is often true in math for lots of things. So this says 4 is not an element of the set A. So anyway, and notice one other thing. Notice every element in A is in B. And so what we actually say, we say A is a subset of B. So the set A is a subset of the set B. What this means is that every element of A is in B. There's also a notation for this. We can either write A is a proper subset of B, or we can write A is a subset of B. And you don't really need to worry too much about the difference between these, but the first one can actually also be written this way. A is a proper subset of B. This means everything in A is in B, but A is not equal to B. This means a proper subset. That it actually is smaller than the set you're comparing it to. Notice this also means then that we can actually write, we could try to write B as a subset of A, but that's actually not true because everything in B is not in A. And I suppose then you could also write B is not a subset of A, looking at it from that point of view. So anyway, there's that.